This question says the data below shows sport preference and age of participant from a random sample of members of a sports club. Is there evidence to suggest that they are related? Okay, so what's the question here? Um, so they surveyed a whole bunch of people and they said, hey, what sport do you like? Tennis, swimming, or basketball, which, among these three, which sport do you prefer? And then they asked, hey, and what's your age? So they surveyed a whole bunch of people and they asked them two questions. Among these three sports, tennis, swimming, and basketball, which one's your preference? And how old are you? And then they put the data in the chart. 59 people whose ages were 18 to 25 years old said tennis was their favorite among these three. 83 people whose ages were 18 to 25 said swimming was their favorite. 74 people in the ages between 18 and 25 said basketball was their favorite. And then for people that were ages 26 to 30, 90 of them said tennis, 96 said swimming, 70 said basketball. People in their 30s, 31 to 40, said 90 of them said tennis, 77 said swimming, 61 said basketball. And people over 40 years of age, 85 said tennis is their favorite, 49 swimming, 53 basketball. Okay, and so the question is there evidence to suggest that they are related? So related is the same as the word connected. In other words, as you get older, does your sport preference change? Is there a relationship here? That's what's really being asked. Are they related? Are they connected? Do they affect each other? In other words, as you get older, do you start preferring different kinds of sports? I think so, because you get older, your body doesn't do what it used to do when you were younger, and might change what sports you like to play. Probably not sports that are quite so vigorous anymore, perhaps. Let's see, is there data to support that idea that the sport you prefer and your age are related? They affect each other. So as your age changes, it's going to change the sports you prefer. Is that true? Well, let's see. So what is the correct statistical test? You can see the answer there's independence. But would you know that if the answer wasn't staring you in the face? How do we know it's independence? Well, let's go down here to the notes. This is the Unit 4 notes. They'll help us to figure out. As I said, it's a test for independence. Why? Because it tests only one sample to see if the row and column variables are connected or related, associated, dependent, affect each other. So one sample. See that? One sample. Whereas homogeneity is two samples, isn't it? You think, well, how do you know if it's homogeneity or independence? Again, homogeneity is two samples. Independence is one sample. Let's go back. You see, well, where did it say one sample? Well, it said, if I say I have a dog, that means I have one dog, right? See what it said here? A random sample, right? That means they did one sample. They didn't have two samples. They didn't have one group of people and a second group of people. This is one sample. One sample, not two. So that tells us right away, oh, okay. It's not homogeneity, because homogeneity you have two different groups. Two different groups. No, this is one sample. So it's independence. Well, and not only that, they're asking us to see if they're related or connected or associated or dependent, affect each other. I think they use the word related, right? If they use any of those words, that's a test for independence. Now, you might say, well, how do you know it's not goodness of fit? Well, goodness of fit has two different forms. Either you're testing to see if all the categories are the same. They're not asking us that. Does everybody like tennis, basketball, and whatever the other one was the same? No, that's not swimming. Swimming, tennis, and basketball, are they all the same? That's not what they asked us. And also, and the other case is case two, category percentages. They didn't list any category percentages. So it's not goodness of fit. It's not home because there's no category percentages. They're not asking if they're all the same. It's not homogeneity. There's not two different groups. It must be test for independence. One sample to see if they're connected, related. That's the word they use, related. So we go, oh, okay. So, right, see right here, it says, whoops, I'm in the wrong. I am totally lost now. There it is. They say right here, are they related? Connected, same thing. So this is a test for independence, right? Kind of like when a child gets older, over 18, and he or she wants to leave the home and be independent, right? They're dependent when they're younger, they're independent later. So independent means separate, doing their own thing. Dependent means connected. So we're testing to see if they're connected, dependent, or independent. All right. So what's HO and H1? Well, once we know that, we just go down and go, okay, what's going to tell us HO and H1? Right here. HO, row and column variables, independent, meaning not related. Like when a child is older and he or she's independent, they're not related, not associated, do not affect each other. Versus H1, they're dependent, they're related, associated, they affect each other. So HO independent, H1 dependent. Go back. HO independent, H1 dependent. There we go. Let's go down and so now we got that. So now it's calculator time. Part C asks for the test statistic and the p-value. Those always come from the calculator. Which calculator are we going to? Well, it says it right here. Test for independence. Online calculator. Test for independence. What a surprise. All right. Let's go there. Test for independence. That is number 22. See it down there? Test for independence. 22. 22. Here we go. Boom, look at that. Big old chart. We're going to just type in all this. Now, you can't copy and paste because they're like separate boxes. They're not just one big box where you can put commas between them or something. So we just got to put them in there. So let's go back, look at the numbers. Wait, where is this up here? There they are. So I'm going to basically put all these numbers in the chart, just like that. All right, I wrote them down in a separate paper. I'll type them in now to the chart. Let's go. All right. So what do we got? 59. Come on down. 90. 90 again. It's a little tedious here. 85. 83. 96. 77. 49. 74. 70. 61. 53. There we go. Got them all typed in. Just hit calculate at the bottom, hit calculate. Boom. Okay, there's the chi-squared. That's the x-squared number and the p-value, 0.00648, so 0.065. Let's go back, see if that's right. Coming on down. Yep, there it is. There's a p-value, 0.065, just like we said. And there's the chi-squared number. That's the x-squared, but it's actually a Greek letter. Looks like an x, but it's a Greek chi, actually chi-squared. Anyway, all right, time to draw some conclusions. Our p-value, 0.0065. How does that compare to alpha? What was alpha? There it is, 0.5. Okay, now which one of those is bigger? Well, if you're not sure, take them over here and line up the decimals. Remember, you want decimal right over decimal. And anywhere you got blanks, just fill in zeros. So now you can say, which is bigger, 500 or 65? Well, 500. Yeah, that way, right? This number's bigger. He's on the wide side of the symbol. You could have messed it up. You could have thought, well, 5 is lower than 6. Yeah, but it's 500 compared to just 65. See that? So if you're ever unsure, line up the decimal right over decimal, fill in any blanks with zeros, and it's easy to compare. 500 is bigger than 65. So the 0.5 is bigger. He's on the wide side of the symbol. All right. So then how do we draw our conclusion? You know, the most important saying, if the P is low, then the HO, the null, must go, meaning go away, right? So if the P is low, the null must go. Is our P value low? Yeah. Yeah, the P value here is less, right? The P value is less, it's low. So if the P is low, the null must go away. So that means reject the null. And here we have that answer right there, reject the null. And for rejecting the null, then we're keeping the other one. Keep H1, right? Whenever you reject the null, then you keep the other one. You keep an H1. So, okay, because you're saying no to the HO, so you're keeping H1. So then what does that mean? Well, remember, come back here. HO is all, in every hypothesis test, is always weak evidence, and H1 is always, in every hypothesis test, strong evidence, okay? So which one are we keeping again? Let's go back and make sure we're clear. We're keeping H1, so come on up here and go to this one. This we're going to keep H1. So what does H1 say? Strong evidence and dependent. Strong evidence dependent. So I'll bring that down. So that means strong evidence and dependent. Dependent. Okay, now they use the words sufficient, insufficient. What does strong mean? Strong means sufficient. If evidence is strong, then it's sufficient. It's enough, right? Sufficient means it's enough. So, okay, so we can get rid of these ones that say insufficient. We got rid of half of them. We got 4 left. So we're looking for ones that say sufficient and dependent. Sufficient, dependent. There it is. We don't want the other ones. Sufficient, dependent. Now watch out. On some of these hypothesis tests, they'll use the other words for dependent. What does it mean if dependent? Remember back in the notes? Let me show you down here in the notes. The other words. They're down here to help you. So dependent is the same as related, associated, affect each other. So we could have looked for dependent, related, associated, affect each other. Any of those mean the same thing, right? Because think about, your family members that are living in your home, like when the kids are under 18, those are your dependents. When they get older and they leave the home and marry their own person and have their own families and kiddos, that's when they're independent. So dependent means they're related, they're connected, they're right in your home. They're associated with you day by day. They affect you day by day. You live together, rub elbows together, right? That's dependent. Right. The other word, independence, when they get older, they're not related. I mean, they are not day by day, not associated day by day, don't affect each other day by day. Right. All right. So ours just use the word dependent, but any of those other words, related, associated, affect each other, would have meant the same thing. And so there we go. Well, and again, how did we know that? Because if the p is low, the null must go, and our p-value was less. So our p-value was low, so the null must go. Reject the null, which means we're keeping H1. If we're saying no to HO, we're keeping H1. We went back to H1. H1 said is always strong evidence, right? HO is always weak. H1 is always strong. And we already said dependent. Strong evidence, dependent. So sufficient evidence, dependent. And there we go.